Hey everybody, I hope you're doing great today. So we are going to tackle one of the more complicated concepts right now. And so if you're struggling to get this, I implore you to keep trying. Don't give up. Ask questions, re-watch the video, look at practice problems in the book. Go to YouTube and Google transformations of linear functions. Right? There are all sorts of things we can do, but don't give up on these. I'm going to come back to 1 and 2 after we go through the straightforward ones here, 3 through 8. So again, if you're getting some of these and you want to pause it and try these on your own, you go right ahead and do that. And in the meantime, we're going to go through these. So we're tasked with writing a new function g of x to represent a new function. So here's what I would say that we do. So on number 3, we know g of x is going to be equal to our function f of x. And then here's what we're translating. We're translating it down 4 units. So we would see that as a minus 4. All right. Now we can substitute back in to simplify this a little bit. So g of x is now going to equal, well, f of x, I know what that is. That's this right here, 9x minus 3. And we can further simplify this down to say, hey, 9x minus 7. There we go. So that's what our new function g of x would be if we translated this function 9x minus 3 down 4 units. So we're either going to, we'll talk about inputs and outputs on here. And you'll see that the ones that we just did, right, when we shift up or down, we're really moving the output, we're not moving the input, and that makes it a little bit easier on us, like number 4. So g of x is going to equal the function f of x. If we're moving up 8, we would see that as plus 8. All right, now let's take 5x minus 12. That's our f of x function. If we add 8 to it, we can simplify to say, hey, g of x has to equal 5x minus 4. And if you're not sure if you got this right, what could we do? Right? Well, here's what Mr. Fricky would do. I would go to Desmos and I would graph 5x minus 12. See what it looks like. Underneath it then, I would graph 5x. That was kind of cool. Minus 4. And I'm hoping when I do that, it moves up 8 units. Right? I'm hoping it's the same function, just shifted 8 units up. Right? So use the technology that we have to make our lives a little bit easier on this. Okay? Number 5. No, I'm going to come back to that one. Let's do number 7. Again, we're shifting 1 unit down. I would see that as a minus 1. So my function g of x is equal to f of x minus 1. So replace f of x now with what we know it to be. This is 0.2x plus 1. If I can write, there we go. Minus 1. So simplify everything. G of x will equal just 0.2x. Okay, up and down, very straightforward because we're just changing the output. I'm not changing the input. Okay, let's see what it looks like when we change the input. All right, depending upon if we have a number outside of our x, it changes them quite a bit. So number 5, here we go. So g of x is equal to f of x, but now it's 3 units to the right. So if I'm going to move 3 units to the right, we really subtract 3 from our input. All right, then we've got this minus 2 to deal with. We can go ahead and nothing to multiply here, right? There's no, there's nothing outside of here. So g of x just equals this x, and then I can combine minus 3 minus 2 just turns into minus 5. These ones are a little bit trickier, right, if you look at number 6, because I have a 3 here. All right, so g of x is equal to f of x right? In this case, we're moving 2 units to the left. So 2 units to the left means plus 2. All right. When I rewrite this, now I have a 3. This 3 ends up being where the f is. So now it's 3 times this quantity, x plus 2. So my new g function is 3x plus 6, just distributive property there. Again, if you are not sure, go to Desmos, graph those two. F of x equals 3x, g of x equals 3x plus 6. All right. Sweet. Okay, let's look at the last one. Again, g of x is going to equal, right, we have our function 2x. It's going to move 5 units to the right. So it would be 5 units to the right. So minus 5. All right. Go ahead, substitute this 2 in where it goes, right here in front of the function. So g of x is equal to 2 times this x minus 5. And distribute, so 2x minus 10. All right, that's what g of x is equal to. Okay. If you guys want to try 1 and 2, right, do that. Again, they're just word problems, but they tell you what the function is, and we've got to write a new function, g of x, on number 1 that's translated down 5 units. On number 2, a line that's 6 units to the right. All right, so if you want to pause that, do both of those, you can. Number 2 more challenging than number 1. So when we solve the first one here, I'm just going to tell you g of x equals, should be 4.2x plus 1.5. All right, number 2, I'm going to say, hey, let's solve this one. I don't really have a lot of room here. All right, to write small. Okay, g of x will equal our f of x function, right? But we're changing the input to 6 units to the right. So it's going to move 6 units to the right, which is really a minus 6. Now, you've got to rewrite where does the 2 and where does the plus 7 go. The plus 7 will go out here. The 2, right, goes over here. So now it's 2x minus 6 plus 7. So let's distribute the 2 first. So g of x equals 2x minus 12 plus 7, and then that will further simplify just down into 2x minus 5. Again, check it out on Desmos if you need to. All right, use that to help you. All right, let's go to the next page. Okay, here we go. So again, if you need to pause, do whatever you need to do. All right, you can try some of these. You can try all of them. All right, transformations are not easier, but they're going to with a little bit of hard work. Okay, so up here, this is everything above here. All right, this is kind of our, hey, this helps me figure out what's going on with my inputs and outputs when I have these A values, right? So here again, you know, you've got to think about, is this affecting my input? Is this affecting my output? And what will these numbers do? All right, so is my graph going to get steeper? Is it going to get, you know, not as steep? Are we going to reflect it across an origin? Are we going to rotate it? What are we going to do? All fun stuff. Okay, there's your, so the green thing, refer back to that. That's your kind of cheat sheet to help you with all this. So 1 and 2 just say, hey, we want you to describe the graph. So I think we can do that. So number 1, again, f of x is just, right, this equation here, f of x equals x. That is, goes right through the origin, looks just like that. Okay, if you don't know, graph it on Desmos. G of x is 0.25x. So if we graph that one, all right, it's going to be, again, that will go right through the origin. It will be less steep. All right. and it's rotated. In this case, it's kind of rotated, down what we would call clockwise. But we can just say it's less steep, and that one's still rotated. What about g of x equals negative 4x? Again, on a graph, it's going to look like that. So if we're comparing here, maybe I should do the new. So there you go. So if we compare the red one to the green one, right, the green one over here, this is our parent function, we'll call it. So it's steeper, right? Negative 4 compared to just 1, so greater absolute value there. So much steeper. And again, this one not rotated, this one actually has been reflected because it's going across our y-axis. So this one gets reflected across the y-axis and becomes steeper. So there was just describing the graphs. 3 through 8, we're going to write a rule for g of x, which I think we can do, and then describe the transformation. So if you're not sure, this is, again, use Desmos, graph these, and then try to describe what's going on. So my main function, f of x, is 4x. My new function says, okay, hey, I want to multiply this input by 1.5. So again, on this one, I'm just messing with the input. So we can say, hey, g of x equals f of x times this 1.5. That's a not very good handwriting. We can plug in 4, all right, over here where it goes. So g of x equals 6, I believe, is what we get when we take 4 multiplied by 1.5, so 6x. I'll just go down. I'll do 3, 5, and 7 first. Number 5, so f of x is equal to 15x. G of x equals 1/5 of f of x. So in other words, I want every output to be 1/5 of its input. All right, so g of x equals 1/5 of 15x. That is some great handwriting there. All right, and that will turn into g of x being equal to 3x. Oh, I forgot to describe the effect that it has. So let's go back to the first one. So if we started off with our function equaling 4x, and then we ended up with 6x, we would say that it's steeper, right? And that one's still going in the same direction. Slopes are the same, both positive, so that one's just rotated. Right? You can say it's rotated around the origin if you want to be really fancy. Number 5, right? Our one function was 15x. The function we got out of that was 3x. Sorry, negative 3x. Lied to you guys. There you go. Somebody caught me. Negative 3x. So again, put those two into Desmos and see what happens. So 15x is our parent. Negative 3x is our new function. So clearly that one is going to be less steep because its slope isn't the same. It's got a different slope. That one's reflected across the y-axis. Okay. Let's take a look at number 7. F of x equals x plus 1. Right, our new g of x function, all right, equals 3 times our f of x function, right? And it's times the whole thing, so times the output, right? Times everything. So it looks like this. So we can say g of x equals 3x plus 3. Again, graph these two. All right, what do they look like? How is it changing? Well, 3x plus 3 is definitely going to be steeper. And again, this one's still rotated. All right. Go ahead, if you want to, pause the video, give 4, 5, and 6 a shot. If you don't, and you haven't paused it, then I'm assuming you want me to yap about them, which I'd be happy to. So number 4, g of x equals, we are doubling just our input on this one. So we're going to take, right, that's just what, when we see these parentheses, that's what that means. So, hey, just double the input on number 4. So we're not going to double everything like we did on number 7. So we are just going to double the input. So it looks like 2 right, times this x, then plus 5. We can simplify all that to say g of x equals 2x plus 5 as I run out of room. Okay. Describe the transformation from here to our new one. Well, it's definitely steeper and clearly been rotated around the origin, right? We only get reflections when our slopes are opposite, right? We go from positive to negative or vice versa. All right, number 6, my g function, right? Again, I'm only changing the input, right? Just the input. So we're only going to multiply 5x by this negative 2, right? Leave plus 6 alone by negative 2, right? So my new g of x function is negative 10x plus 6. Okay. How does that compare to the other one? Well, it's definitely going to be steeper, right? Because negative 10 has a greater absolute value compared to, I'm sorry, negative 10x compared to 5x, right? That's a greater absolute value. So it's going to be steeper, and because our slope went from being positive 5 to negative 10, it's reflected across the y-axis. Our last one, here we go. F of x is 2x minus 4. G of x is a 1/2, or 0.5, of the entire function. So again, output is getting multiplied. So g of x, right, will equal half of the entire function, 2x minus 4. Okay, so half times 2 is just 1x. Half of negative 4 is just negative 2, or minus 2. So there's your new function. All right, compared to our original function right here, 2x minus 4, this one will be less steep. Still has positive slope, so that one will be rotated. Right, that one will be rotated. All right, if you want, move on to pages 3 and 4. Answers will be back on the website for those two. Again, I know this stuff isn't easy, right? But don't give up, and do your best, and keep going on and ask questions, and we will make it through all of this. Okay, have an awesome rest of the day. Raise your hand, and I'll answer your questions. Go get them.